Chapter 2, Section 6 is about ratios and proportions. The first thing I want to go over is some vocabulary words that I want you to be familiar with so that when I say these words in this video and as you start reading through the problems that you know what they're asking you to do or find. So first, a ratio would be a comparison of two numbers using division. So what I want you to think about here is that you're going to start to see fractions. I could compare like the number of boys to girls in a classroom, or the number of dogs to cats, apples to oranges. I could compare any two quantities that I wanted to by using a fraction. Then I could take that fraction and actually create what's called a proportion if I have more than one fraction that I'm comparing. Now, the thing about a proportion though is that the two ratios or fractions that you have set up should be equal to each other or equivalent. So we are going to have an equal sign in the middle that states that these two ratios would be the same. Now later in this section we'll talk about something called a scale. Scales are used when you're making a model of something. And what this does is it compares the real life size of something to the model size. A lot of times where you'll see things like this is if somebody is doing building a new house or building a business building or a shed or a garage or something. They will have a blueprint drawn up first that kind of details what the building is going to look like or what the house is going to look like. And in that blueprint, you're going to have a scale of this many inches on the drawing is going to represent this many feet in real life. And all of that information would be used or represented by a scale. The first thing I want us to practice, though, is determining whether two fractions are equivalent to each other. And remember, equivalent means equal. Now, when you're given ratios like 4/9 and 12 over 27, you could try to reduce your fractions, but I want to show you a method that some of you might be familiar with, where you're testing to see if these two ratios are equal to each other. This method you may have learned at an earlier age as the butterfly method. We are going to call this cross products or cross multiplication. So we multiply diagonally on our problems. Now what we're looking for here when we multiply diagonally, so when I take 4 times 27 and 9 times 12, I'm trying to see if they are equal to each other. If I multiply these, I get 108 equals 108. So we would say, yes, they are equivalent. But if I had something that came out to be 108 equals 115, those would not be equivalent, and I would say no. So why don't you take a minute and do this practice problem and see if these equivalent ratios are a yes or a no. So I'm going to start by setting up this problem the same way that I set up the first one. I'm going to use cross multiplication here. So 2 times 9, testing to see if that's the same thing as 7 times 4. And I get 18 equals 28, which is not the same, so this one should have been a no. They are not equivalent. Now using that method, that butterfly method, I'm going to solve proportions. So in these cases, you know that they're going to be equal to each other because they have it set up with an equal sign. But if you notice, there is something missing from the fraction. So on this one, there is an x on the top of that first fraction. So what I'm going to do first is cross products. I'm going to take x times 8, or I'm going to write that as 8x. Then I'm going to take 3 times 5, which would be 15. Now we're back to solving a one-step equation here, and you've been doing this all chapter long. So now what I'm going to do is divide by 8 on both sides. And I would leave this as 15 over 8 because 15 is not divisible by 8, but there's really no way to simplify that. And I would just leave it as the fraction. So I want you guys to try the next practice problem. So again, I would start by cross multiplying. Now this one has 2x. So you're taking 2x times 7. 2 times 7 would be 14. And then x is next to it. Equals 3 times 6, which would be 18. Then we're going to divide both sides by 14. And again, 18 is not divisible by 14, but we can reduce that fraction. You can take a 2 out of both and get 9 over 7. Now this next example here is still solving a proportion. We're still going to use cross products, but be really careful with ones like this because it has that quantity on the top, x minus 3. It doesn't just say x or 2x like that last one did. It has a letter, but then it's adding or subtracting a number. So when you cross multiply on one like this, you're taking 5 times the x minus 3. You will need to use the distributive property because you have to take 5 times the x and times that minus 3. On the other side, you have 15 times 3, which is what you saw in those last couple of problems. Over here, I would distribute, so draw those arrows if you need to remind yourself to multiply 2 times. We have 5x minus 15 equals 45. Then I'm going to add 15. So I have 5x equals 60 and divide by 5. And I'm left with x equals 12. So I want you to take a minute and try to do that same process for this practice problem. Again, you'll have to make sure that you took 8 and you distribute to that x plus 4. And then take 5 times the 3. So distribute the 8. You should have 8x plus 32 equals 15. Then we subtract 32. So we have 8x equals negative 17 and divide by 8. And again, I would have left it as that fraction, negative 17 over 8. Now we're going to get into some story problems next. And when you're doing story problems that involve these ratios and proportions, you're going to want to follow these couple of steps. Step 1 would be to determine from the problem how you want to set up the ratio. So in these problems, you're going to be dealing maybe with a scale, or they're going to be talking about comparing minutes to miles or hours to miles or something like that. And so you will have to make the decision of how do I want to set up my ratio? Do I want to put minutes on top and miles on the bottom, or do I want to switch it around? Once you've decided how you want to set up your proportions, that's step 2. Set them up using the method that you've decided so that you have them consistent with each other, and then you're going to solve them. So determine the strategy, which would be using cross products, like we've been doing, and then you're going to solve for that problem. This next example I have worked out here for us, but we're just going to read through it and make sure that you can kind of follow along. So the gear ratio on a bike is 8 to 5. So that means for every 8 turns of the pedals, the wheel turns 5 times. Suppose that the bicycle wheel turns 2,435 times. How many times would you have to pedal? So to set this up, they decided that they want to put the number of pedals over the number of wheel turns. So from the ratio, they put 8 over 5 because 8 pedals turns the wheel 5 times. And then they set that equal to P over 2,435 because we're trying to figure out how many times we would have to pedal, and we know how many times the wheel turned. So they cross multiply. They got 8 times 2,435 equals your 5P. So we got this 19,480 when we multiplied those two together. and then we divided by 5 on both sides to get that 3,896. And that would be 3,896 times that the person had to pedal in order to get the bike to turn that 2,000 sometimes. So let's do this first practice problem together. It takes Kara 7 minutes to walk around the gym track twice. How many times can Kara walk around the track in half an hour? So I'm going to put minutes, not minutes, yes, minutes on top over the number of laps. So in 7 minutes, she can walk around the gym track twice, which would mean she did 2 laps. And I'm going to set that equal to, I want to figure out how many times Kara can walk around the track in half an hour. So how many laps can she make? So X needs to go on the bottom in half an hour, which would be the same thing as 30 minutes. Then we cross multiply. So we have 7x equals 60. So take a minute and do this practice problem. So if you follow the first practice problem, the setup would look very similar. You could still put minutes over laps. So I would put 5 over 2. And then this time, though, you have 45 minutes on top and x on the bottom. And then we cross multiply. So we have 5x equals 2 times 45, which would be 90. And then if you divide by 5, we get x equals 18 laps. For this next example, they're talking about the scale on a map of the Great Smoky Mountains, and they're saying that 3 inches is the same thing as 10 miles on the actual map, or on the actual mountains. They are then saying that if they're looking at a portion of the map that's 1 1/8 inches, they want to know what's the actual length in miles on the mountains. So they decided to set up their scale as inches over miles. So 3 over 10, that comes from the scale, and then 1 1/8 over m for miles. And then they cross multiplied here. So 3 times m, and then that 1 1/8 times 10. Now they do suggest that you convert your mixed number to an improper fraction to make the multiplication easier. So that became 9 over 8, and then you're multiplying that times 10, which would be 90 over 8 equals 3m. Then they divided both sides by 3, or they switched that to 1/3, because when you're dividing a fraction by something, you want to multiply by the reciprocal. And so you got 90 over 24, or they reduced it before they multiplied to get 30 over 8, which can still reduce down to 15 over 4, which if you convert that back to a mixed number, would be 3 3/4 miles. So for this last example here, this model airplane has a scale factor of 5 centimeters to 2 meters. So I'm going to set this up as centimeters over meters. And I'm going to put 5 over 2. Now the wingspan on the scale is 28.5 centimeters. So 28.5 should go on the top. And your variable should go on the bottom for the actual wingspan. Then we're going to cross multiply. And so we have 5x equals 57. Then we'll divide by 5 and get 11.4 meters.